Hey everyone, in today's video we're going to be talking about systems of equations, and this particular video we're going to be talking about how to solve by substitution. So we already have a video on graphing these systems of equations and also elimination and how to solve using your calculator. There's lots of different ways you can solve. So here is substitution. Alright, here's all the steps. You might want to take a picture of the steps because we're actually going to go ahead and just use them. So we'll have this up here for your info, but we want to make sure when we're substituting one of our equations is already x equals or y equals. So that's what this is saying. So we just want it to look like x equals something, y equals something. Okay, and then we're going to actually substitute the whole chunk for whatever that equals into our other equation. And then we solve. I think this makes more sense when you actually just do it. So you're welcome to reference back this slide, but let's go ahead and actually just try it. So remember, the first thing I need is to either be y equals or x equals. So right now with these two equations, I don't have that. However, I can rearrange my functions and equations so that I have either x equals or y equals. It doesn't matter which one, whichever one's easier. I'm going to rearrange this first one, and I'm going to add the y to both sides. So x equals 11 plus y, or y plus 11, same thing. If you'd rather solve for y, you can do that too. But then I got a negative to deal with, and I don't want to do that. So it's not wrong if you do. So you choose your way. Now, let's see if I can get a, not erase. Here we go. See if I can get some color options for you. Here we go. Highlighter. I'm going to take this whole chunk right here, because I'm telling you this is what x is, and I'm going to replace this x here with that chunk of values. So we're going to take this 11 plus y, and we're going to actually plug that in to x. So you might want colors for this. I found that it's helpful to see it. So I'm going to write 2, and instead of writing x, so I'm rewriting this equation, I'm going to write 11 plus y. Okay, because I'm saying x is 11 plus y, so you can replace or substitution, your values here. So, and then plus y equals 19. So literally just replacing the x with this thing right here, that whole expression. So now I'm going to go ahead and distribute. So 22 plus 2y plus y equals 19. I'm going to rewrite this 3y plus 22, just so it's in standard form, equals 19. Subtract 22 on both sides. It's just solving equations. I'm going to get negative 3, and then y here is going to equal negative 1. Okay, so I've got one of my values. Remember, my answer is a coordinate point, and I know the y value is negative 1. Or you could leave it as y equals this, x equals that. Okay, so I'm going to take this negative 1 right here, and I'm going to plug that into either this y or this y. You pick. I'm going to pick the top one because it looks a little bit easier. So I'll do both so you can see what happens. So I have x minus negative 1 equals 11. So x plus 1 equals 11. So then x equals 10. So now I'm going to plug it into the second equation here, just to check. So I have 2x plus negative 1 equals 19. So I have 2x minus 1 is what that is, equals 19. So 2x equals 20, oh, right and sideways, that's okay. X equals 10, oh good. So both times, maybe, there we go. So both times I solve this, either the top equation or the bottom equation, I'm getting x equals 10, which means I've solved it correctly because I got the same value. Okay, but you don't have to do both to solve the equation. Just pick one, whichever one looks easier. I personally think the top one looks easier because there's less going on. You don't have as many big coefficients. Your factors are smaller. Okay, and that'd be your answer, 10, negative 1. And that's your answer for that one. I'm checking to see how many we have. Just got a couple more. All right, you try these. Go ahead and pause the video and try it. I'm going to go ahead and jump in. Pause it. All right, so right here I have y equals 6x minus 11, so I'm going to replace it with this y. Again, feel free to color coordinate, it might help you out. 2x minus 3, and instead of putting y, I'm putting what y equals, which is 6x minus 11, equals negative 7. clean it up a little bit. When you do the substitution, like when you're at this step here where you're plugging things in, you want to either have just x's or just y's. So here, notice I have x's. I don't have any y's. If I have one of each, I still can't solve it. I'm not done yet. Just pay attention to that. That could help you save some time if you made that mistake. All right, distributing the 3. So negative 18x and then positive 33 equals negative 7. Let's clean this up a little bit. Negative 20x. I'm going to go ahead and subtract 33 on both sides. You might have done this in more than these steps. That's fine. Negative 40. So x equals 2. All right, so I'm getting x equals positive 2 for this one. Okay. You can plug it in again, either top or bottom. So you can either plug in the 2 here or plug in the 2 to the bottom. I'm going to do the top one because it just looks easier because y is already isolated. So if I do 6 times 2 minus 11, that's just a simple problem here. 12 minus 1, 11, excuse me, equals 1. So y equals 1. And again, you can write that as a coordinate point. Or sometimes, and this depends on your teacher or whatever program you're using, you can do x equals this, y equals that. As a teacher, I take either one. So, but ask, find out. Oops. Okay, and if you wanted to plug it back into both sides to check it, you can. So if you wanted to plug in a 2 here for the x and for the y, plug in a 1, we would get negative 4 minus 3 equals negative 7. Well, I get negative 7 equals negative 7. That's the reflexive property, and that means that my number, my solution here, works. Okay, it would need to work for this top one too. And we know it did because that's where we plugged in our 2 right here. Okay, I'm going to do the bottom one now. If you haven't paused it, haven't done it, pause it. I'm going to add the 5x to both sides. You might take more space than I take. That's totally fine. I'm kind of running out of room here, so I would take more space than I'm taking. All right, so I'm going to rewrite this as y equals 5x minus 2. I like to be in standard form for these. Okay, so here's my y. Y equals this little chunk of stuff. So I'm going to replace this y. So negative 3x plus 6 times y, distributing the 6 to the whole thing, equals negative 12. This 2 looks weird, doesn't it? Odd. Font issues. That's okay. We're realistic here. All right, negative 12. All right, I just distributed. That's all I did. Okay. All right, so I've got 33x. I was checking my key. And then I've got negative 12, but when I move that, I add my 12 to both sides. Negative 12 plus 12 equals 0. Stop. Pause. A lot of people like to say, oh no, it's 0. There must be no solution. You guys, 0 is a number. It's okay. We're good. We're still okay. Calm down. Okay, so this just means right here, and I'm sorry I ran out of room. Sorry if I freaked you out, but x equals 0. That's okay. Numerically, that's fine. We're totally okay with this. Okay, and actually that kind of makes my problem easier to do because I'm going to plug this into, I'm going to do the top one. I know my face is over here somewhere. I'm trying not to write on me. So 5 times 0 plus y equals negative 2. This whole part cancels out. So look, y equals negative 2. All done. And that's 0, negative 2. Again, you could take your values, plug it back into both x and y for both equations. You want to end up with some number equals itself. If it doesn't, then go back and redo it. Okay, but that's our answer for the second one. I like systems of equations. It's one of my favorites. All right, here's some exceptions. All right, it's our last slide. Go ahead and pause it and do the first one. See what happens. I'm going to go ahead and do this. I'm going to move the bottom one. So I'm going to have y equals x plus 3. Again, I just added x to both sides. And then I rewrote it. I'm allowed to do that. Commutative property. Negative 3x plus 3 times x plus 3 equals 4. Okay, let me go ahead and distribute. Negative 3x plus 3x plus 9 equals 4. Watch what happens. negative 3x plus 3x. Well, that's just 0x, right? So 0x, that's always going to equal 0, so I don't need it. So I end up with 9 equals 4. That's very interesting because I'm pretty sure 9 doesn't equal 4, right? Okay, so anytime this happens, your variable disappears. Okay, so over here, your variables, your vars, disappear. Oh no. So then I don't even know if I need a 1. I'm gonna erase the 1. So if the variables disappear, okay, if you get a, let's call it a false statement. So a false statement, like this one's a false statement, okay, then that means it's no solution. Okay, this goes back to our graphing. If you actually graphed these two on a coordinate plane, you would find that they are parallel lines. So this one has no solution, and it's no solution. So you can use an empty set, you can write out the words. Just depends on what format you prefer to use, or if your teacher has a preference. All right, do the second one. If you haven't already, pause it and do that second one. Let's see. Whew, a lot to move around here. I think I'm gonna move x on the top one, just because I got factors. Might have fractions when you do substitution, and that's okay. It happens. Not personally my favorite, but we'll be fine. All right, divide by 2. All right, I'm just rearranging the first one. So I'm going to get x equals negative 4y plus 3. Okay, remember the 2 has to go to each term on top. All right, let me plug this in. Here, I'm going to do this over here. Negative 5 times negative 4y plus 3 minus 20y equals negative 15. That 5's in a different font too. Whew. I'll put hidden Easter eggs in here and you can see what's weird. All right, so I've just distributed my negative 5, right? Let's clean this up. I have 20y minus 20y. Uh-oh, okay, there's my variables disappearing, right? And these are the exceptions, so we're expecting this. You get negative 15 equals negative 15. Okay, I know if it's a false statement, it's no solution. However, does negative 15 equal negative 15? It does. So if you get a true statement, then that would be infinite solutions. So this would be infinite solutions. Infsol. Probably better if you write the whole thing. Now, I don't say all real numbers for this one because they're going to be infinite solutions on this, on the line. So if you go back to our graphing video, you'll see when you have, it's 2 equations, but it actually ends up being the same line. So it's just the same equations with different factors. So that's why it's infinite solution. I wouldn't put all real numbers again because every single number won't work. It's just infinite solutions that are on that one graphed line. Okay. And those are your exceptions. So that is systems of equations by substitution. So when should you use substitution? Because you can do graphing, and it will show you how to do elimination. I won't show you how to do Cramer's rule, but I'll show you how to use a shortcut. And there's all these different ways you can do systems of equations. It's kind of cool how it all comes together in all these different ways. But I would only use substitution if your y and your x, your y, your x and y are already isolated, and the coefficients, remember that's the number in front of the variable, they look like they're going to be easy to work with. No fractions, preferably. So what that means to me, like down here, this bottom one right here, if I was just told solve this system in any method, I personally wouldn't use substitution on that because that one looks crazy. But like this one here, look at that. That y is already by itself. That's nice. I can plug that in. Okay. So that's when I would use substitution. Again, we have other videos on the other methods and when you should use each of those other methods. All right, that's what I have for you for this video. I hope you learned something. Give us a thumbs up if you did, and subscribe to our channel to keep up with the other content that we have, and you'll see the other types of solving systems and lots of other fun content. All right, thanks guys. Have a great day. Bye.